Next, we're going to talk about combination of functions. We can perform operations on functions. We can add functions, subtract from functions, multiply and divide functions, and here are the rules. When we have this operation f plus g of x, then all you're going to do is take f of x and then add the g of x. Notice that your sign here, the addition sign here, stays the same. Okay? So the add and the add are the same. Next, we can subtract. F minus g of x is equal to f of x minus g of x. F times g of x is equal to f of x times g of x. Now the one that's a little bit tricky is the last one, divide. F divided by g of x is simply f of x divided by g of x. That part is pretty simple. But then there's this extra thing here. G of x cannot equal 0. Why in the world do we have this restriction? Well, we know we can never divide by 0. So, like if I have 4 divided by 0, that's undefined. Okay? Well, g of x is a function of a variable x. Because we have a variable, that means our values for g of x change. So at some point, g of x in the bottom may be different depending on what your variable is at the moment. So if that function g of x ever has a point at which g of x is equal to 0, then we're not allowed to have that. So we have f of x over g of x. If at any point, if g of x is equal to 0, then my whole function is also then undefined. So as long as g of x is not 0, then f of x over g of x is defined. So because of that one particular case where g of x might make the denominator 0, we need to be a little bit careful when we're dividing functions. Alright, so let's try these problems here. So on my next set of problems, I have f of x is equal to 6x minus 1, and we're going to use red every time we see that, and then we're going to do g of x is equal to 2x minus 3 every time we see that. So if I'm trying to do f plus g of x, well, I know by definition from above that's f of x plus the g of x function. Now I know my red f of x function, I can replace that with 6x minus 1. My addition sign is going to stay the same because that's what we were asked to do, and then my g of x, I'm going to replace that with 2x plus 3. Once you see this together in one polynomial, we can just combine like terms to get 8x and minus 1 plus 3, that adds to 2. So therefore f plus g of x is equal to 8x plus 2. So I took a f function and I added a g function to it, and I got a totally new function f plus g, and that new function is 8x plus 2. Next I'm going to do f minus g of x, which by definition is f of x minus, because the problem asked me to subtract, g of x. So the f of x is 6x minus 1. The subtract stays, and this time, because subtract is a little bit more difficult than add, we need to remember that for the g of x function, I need to put a parenthesis around that g of x function. The reason I need to do that on this one, and I didn't need to do it on the previous ones, is I need to distribute that negative to every single term in the g function. If you don't put the parentheses, the mistake students will make is they will only subtract the first term, 2x. They'll get the minus 2x just fine, but they'll forget to distribute the negative and subtract the 3x. So make sure you put parentheses whenever you're using addition or subtraction. Now I'm going to combine like terms. 6x minus 2x is 4x, minus 1 minus 3 is minus 4. Therefore f minus g of x is equal to 4x minus 4. Next we have f times g of x, which is f of x, multiply, because my operation is multiply, g of x. My red f of x function is 6x minus 1. Again, I'm going to use parentheses because I need to multiply the entire polynomial f of x times the entire polynomial g of x. Now I can distribute. 6x times 2x is 12x squared. 6x times 3 is 18x. 1 times negative 2 is negative 2x, and 1 times 3 is negative 3. Now I'm going to combine my like terms here in the middle, which gets me a positive 16x. So therefore f times g of x is equal to 12x squared plus 16x minus 3. Our last one for this set of f's and g's is f of x over g of x. So my f of x function in red is the 6x minus 1 divided by my g of x, which is 2x plus 3. And there's nothing else I can do to reduce that. So this one is like one of the easiest ones, except we have that stipulation where we need to make sure that whoever's reading my work here knows that g of x is not allowed to be 0. So f divided by g of x is defined as 6x minus 1 over 2x plus 3 as long as g of x is not equal to 0. So where could g of x be equal to 0? The way I'm going to figure that out is I'm going to set the g of x, 2x plus 3, equal to, not equal to 0, and then I'm going to solve. So I have x cannot be equal to negative 3 halves. That is definitely part of my answer. If you don't put that with part of your answer, then it's not correct entirely. It's going to be partially correct. F divided by g of x is 6x minus 1 over 2x plus 3, as long as x is not negative 2/3. That is your complete answer. Just for a little bit of clarification, if I were to plug in 2/3, so if I did f over g of negative 3 halves here, I would get 6 times negative 3 halves minus 1 over 2 times negative 3 halves plus 3. So the 2's divide in the bottom and I get negative 3 plus 3. In the top, I'm going to reduce that and I get negative 9 minus 1, which gets me negative 10 over 0. Okay, that's a problem right there. We are not allowed to have 0. So my function truly is the 6x minus 1 over 2x plus 3 as long as we pick any x in the whole entire world except 3 halves. 3 halves is the only value that will not work. So you don't actually have to plug in the negative 3 halves. I was just doing that to show you why it got you an undefined answer. And because it's undefined, it is not part of our domain for that function. So let's try this again with p of x equals 3x plus x plus 4, and we'll use that in red. And then we'll have q of x equals x minus 1, and we'll do that in blue. So when I have p plus q of x, by definition that's p of x plus q of x. My p of x is 3x squared plus x plus 4. I'm adding, so no need for parentheses here. My q of x is x minus 1. So I'm going to combine like terms, and I have, let's see, x cubed, 3x squared, 3x squared has no like terms, so I'm just going to keep that there. Then I have plus x plus another x, so that's a total of 2x. Don't forget that when you're adding the coefficients in front of the variable, so 1 plus 1 is 2, the variables stay the same. And then plus 4 minus 1 is plus 3. Next I have p minus q of x, which is p of x subtract q of x. Now don't forget, when you subtract, you'll need to put parentheses around the q of x, the second function. So p of x is 3x squared plus x plus 4 minus, I have a parentheses around my q of x, which is x minus 1. Again, I put my parentheses around the second one so that I remember to distribute a negative or a negative 1 if you prefer to have the negative 1 there. So I have 3x squared plus x plus 4 stays the same. When I distribute the negative, that gets me negative 1x. Negative 1 times negative 1 is plus 1. If you're getting a minus 1, you're forgetting to distribute all the way through. You're just distributing to the first term, which is a common student mistake. Alright, so when I combine like terms, my p minus q of x, I have 3x squared, doesn't have any other like terms, plus x minus x, that adds to 0. So putting 0x is not very helpful, so we're just not going to even bother writing it. If you don't have a term, if you have 0 of that term, you just don't bother writing it. And then I have plus 4 plus 1, which is plus 5. And that is my answer for p minus q of x, 3x squared plus 5. Next, I'm going to multiply p times q of x, which by definition is p of x times q of x. So my p of x is 3x squared plus x plus 4 times my q of x, which is x minus 1. Because I'm multiplying the entire function by another entire function, I need to put parentheses around both of those polynomials. I'm going to distribute the 3x squared first, so 3x squared times x is 3x cubed. 3x squared times negative 1 is negative 3x squared. Now I'm going to grab the positive x, and that's going to distribute to both terms to get plus x squared minus 1x. Lastly, I take the 4, the positive 4, and the positive 4 needs to distribute to both. So that gives me plus 4x minus 4. So I should have 1, 2, 3, 4, 5, 6 total terms there. If you don't have 6 terms, you're missing some of the distributing. So p times q of x, when I combine my like terms, 3x cubed doesn't have any like terms, minus 3x squared plus x squared. Don't forget there's a 1 there, so I'm adding my coefficients to get negative 2x squared. Notice the x squared stays the same when we're adding. Minus 1 plus 4, that's plus 3x. And then minus 4 doesn't have any like terms, so that comes down as well. So my final answer of p times q of x is 3x cubed minus 2x squared plus 3x minus 4. On our next problem, p divided by q of x is equal to p of x divided by q of x. So my p of x in my numerator is 3x squared plus x plus 4 divided by my denominator, which is q of x, which is x minus 1. And that's as far as we can go right now. The only thing we have to do as well is tell where the function q of x would be equal to 0 or not, where it's not equal to 0, so that we have a domain for my function. The p divided by q of x truly is our answer, 3x squared plus x plus 4 over x minus 1, and it's true all the time, except for the one place that the denominator might accidentally be 0, because x is a variable, and variables can change because that's what a variable is. When I set it equal to 0 and solve, I get x is not equal to 1. So the answer is truly my polynomial divided by my polynomial over here, as long as x is not equal to 1. If you don't put that with your answer, then you have an incorrect statement. You're saying p divided by q of x is always this answer, 3x squared plus x plus 4 over x minus 1, but it's not always. It's almost always. that works all the time except for the one case where x is equal to 1. If I were to plug 1 into the denominator, I get 1 minus 1, which is 0, and then the whole function's undefined. So basically, this q of x equal to 0, we're trying to find out where is the one value that would be bad and take that out and tell my reader, hey, p divided by q of x is this, except it doesn't work at 1. And that concludes combination of functions.